The Weibull function and the EXPONDIST function are the same if alpha equals 1 of the EXPONDIST and lambda equals 1 over beta in the EXPONDIST. So alpha equals 1 in the Weibull function and lambda equals 1 over beta in the EXPONDIST. In this video, we will generate the dataset of EXPONDIST and Weibull, where our beta ranges from data validation, list of items, 0 0.5, 0 0.8, 1, 1.25, and 2. So here are the values of beta. And our alpha is 1. And we just choose 1 for now. And our lambda of the EXPONDIST is equal to 1 over beta. Now we can use array formula to generate our dataset, starting with the probability density function of Weibull and EXPONDIST. Array formula: Weibull of the x values and the value of alpha, the value of beta, and because it's probability density function, it's 0. And here's the trend line of the dataset of the Weibull in the probability density function. We'll do the same thing for the Weibull here, or the EXPONDIST. This is equal to EXPONDIST, array formula, EXPONDIST of the x values, and this time our lambda is this value, and our last argument is 0 because it's probability density function. And here you have the trend line in red of the EXPONDIST. You'll notice they have the same trend line equation in the exponential form. That's 1 times e to the minus x because our alpha is 1, our lambda is 1. So that's the form of the EXPONDIST. It's a decaying function. Next we go to the cumulative distribution function, which is array formula, Weibull of the x values. Our alpha will be this value, our beta will be this value, and this time the last argument is 1 because it's cumulative distribution function. And here we have the trend line of the cumulative distribution function, which is a saturating exponential function. And this is the Weibull function, and this is the equation or the trend line equation. Next we enter the EXPONDIST. Array formula, EXPONDIST of the x values, and our lambda will be this cell, and 1 because it is a cumulative distribution function. And in green, same as yellow, they have the same trend line equation and the data sets are the same. Likewise, in the probability density function, the data sets are the same. Now we can start with 0.5. So our trend line equation of the probability density function is 2 times e to the minus 2x, which is the reciprocal of 0.5. And at 0.8, that is 1.25 times e to the minus 2x. So 1.25 is our lambda. And this is our saturation or the cumulative distribution function. We'll have this. And at 1, at beta equals 1, our lambda equals 1 also. So we have 1 times e to the minus x, 1 times e to the minus x. And this is the equation of the saturation, which is the cumulative distribution function. And this can be 2. So here we have the decay function. It is 0.5 times e to the minus 0.5x because our lambda is 0.5. And the saturation will be this polynomial. This completes the use of array formula and data validation in generating the dataset and trend line of the Weibull function and the exponent.